y. And you know, because these two notations are okay, good evening and welcome to today's session. Today I'll be talking about logarithms. Last week we talked about surds and 2 weeks ago we talked about indices. Now indices, surds and logarithms, they are related. They are kind of like a bunch of three topics that are really similar, all right? And they share quite a lot of similar rules and formulae, all right? So today we're going to work on logarithms and okay, logarithms, it's just like that. If y equals to log to the base of x, all right, so this is y equals to log to the base b of x, then x is simply b to the power of y. All right, so this is two different notations of exactly the same thing. All right, one is the logarithm notation, the other one is the index notation. All right, so you see they are both similar, they express the same information, they give you the same information, but they are expressed slightly differently. All right, kind of like two different languages. All right, so here is in the language of logarithm, this is in the language of indices. So y equals to log to the base of b of x, therefore x equals to b to the power of y. And you know, because these two notations, I would say, are very commonly found, you've got to be able to switch between one and the other very fluently. All right, so you've got to be able to begin here and switch to the other side, and you've got to be able to begin the other side and switch to this side really fluently. All right, the more fluent you are in switching between these two notations, the better you will be. All right, the better you will be at solving questions. All right, so you know, throughout our this whole session on logarithms, be prepared to switch between these two notations interchangeably. All right, now for logarithms, there are 6 rules that you need to know. There are 6 rules, and these, the first 2 are here. Right, very simple. So log to the base a of x plus log to the base a of y is simply log to the base a of x times y. All right, so this is the first rule you need to know. We'll be using this rule, you know, over and over again. All right, the second one is this: log a x over y equals to log to the base a of x minus log to the base a of y. So these are the first 2 rules. All right, there are 6 of them. The third one is this: log to the base a of x to the power of n equals to n times log base a of x. All right, this is the third rule, and we'll be using this a lot as well. In fact, all the 6 rules, you know, regarding logarithms, we'll be using them over and over again. So these are the first 3. The fourth one is this: log base a of a is simply equal to 1. All right, and this is the fifth one: log base a of 1 equals to 0. And the last one is this. This is very critical. This is absolutely essential in some of the questions we'll be solving later. All right, and this is really changing the base of the log. So here you can see that it's a log base a of b, and on the right side you will see that I've expressed a and b in terms of a completely different base, and that base is c. So this is the change of base formula. Very critical. All right, we'll see later. So these are the 6 rules. All right, so again, just to repeat, you need to be fluent in changing back and forth between these 2 notations. All right, and these are the 6 rules we will be using over and over again. All right, so let's begin with some simple questions. So here you have a question: evaluate log to the base 10 of 100. Very simple. So you see that 100 equals to 10 to the power of 2. All right, 100 equals to 10 to the power of 2. And what you do is just this: you bring 2 down. All right, you bring 2 down using this particular rule. You bring 2, n here is 2, so you bring it down, and n becomes in the front here 2. All right, and log 10 of 10 is simply 1. All right, so you're using this rule here: log a base a of a equals to 1. So this here becomes 1, and 2 times 1, of course, is just 2. Really simple. Of course, in reality, you should be able to do this without writing the rules down. You should be able to do this in your head. All right, so internalize the rules so that you'll be able to do all of these things up in your head. All right, without writing these rules down. Here, of course, because this is the first few questions, I'm writing the rules for you. All right, so bring the 2 down. All right, so you have the 2 here. All right, and log base 10 of 10 is simply 1. So 2 times 1 is 2. Now let's do a second question. This looks slightly different and slightly more difficult because this involves a surd. All right, so it involves a cert right over here. All right, so it's very simple. And remember, you know, you've got to, when you come to the lecture on log, when you come to the topic on log, you really have to have your indices, your index, you know, rules of indices at your fingertips. All right, so here, you see 27 is 3 to the power of 3. All right, this must come automatically to you. 27 is 3 to the power of 3, and square root of 3 is 3 to the power of half. So how do I get 3 to the power of 3 is 27. 3 to the power of 3, square root of 3 is 3 to the power of half. All right, and because it's a multiply here, all right, so you can add up the indices, all right, add up the powers, and when you add 3 and a half, you get 3 and a half there. All right, so you get 3 plus half equals to 3 and a half. All right, and that's just rules of indices. All right, and you bring the 3 and a half down, and you have that 3 and a half. This has been brought down, so this is log 3 of 3. And of course, this has a value of 1. All right, and then the answer is just 3 and a half. Very, very, very simple. All right, so you really have to have your rules of indices really at the tip of your fingers. If you have it at the tip of your fingers, you will see that logarithms, the chapter on logarithms, comes very, very naturally, right? Okay, now evaluate log 5 of 125. And 125 is 5 to the power of 3, all right? 5 to the power of 3. All right, and bring that down. So that's 3 log 5 of 5, and that is 1. Okay, and so here is just a 3. All right, so you have all, really have to have all these at the tip of your fingers. Evaluate log to the base 2 of 0.25, and 0.25 is 1/4. All right, immediately make the connection. 0.25 is 1/4, and 1/4 is 1 divided by 2 to the power of 2, and that is 2 to the power of minus 2. And you see that this can be brought to the front, so that's minus 2 log base 2 of 2. And log base 2 of 2 is simply 1, all right? And you have your answer there, minus 2. Your answer there is simply minus 2. Really, really, really simple, okay? So log base 4 of 1 over 128, a little bit tricky here, a little bit tricky, but you have to remember that 4 is 2 to the power of 2, and 128 is 2 to the power of 7. All right, so here you really have to make some connections here. 4 equals to 2 to the power of 2, and 128 is 2 to the power of 7. So here I'm going to employ a change of base rule. So I'm going to employ a change of base rule. I'm going to change the base to 2. All right, why have I done that? Because 4 is 2 to the power of 2, and 128 is 2 to the power of 7. So to make things a lot easier, I changed the base to 2. So here it's log base 2 of 1 over 128 and log base 2 of 4. All right, and of course it's very, very simple. That is 1 over 128 is 1 over 2 to the power of 7. 4 is 2 to the power of 2. All right, and I do a little bit more. 2 to the power of 1 over 2 to the power of 7 is 2 to the power of minus 7. All right, 2, I bring it to the front, I get the 2 here. All right, and over here, I've also bring minus 7 to the front, and I've got log 2 of 2 is 1, log 2 of 2 is 1, and I cancel both of them away. And so I have the answer, which is minus 7 over 2, or minus 3.5. All right, so, I encourage you to get to the point where you know all these numbers, at your fingertips. 4 equals to 2 to the power of 2, 128 is 2 to the power of 7, 256 is 2 to the power of 8, and so on and so forth. And you will get there without memorizing. You will get there by doing lots and lots and lots of questions. Okay, so evaluate log base 10 of 0.00001. Okay, the first thing you do is this. You change this to scientific notation. So that's, you look at this decimal point here. This is 1, this is 2, this is 3, this is 4, and this is 5. So really, this is log base 10 of 10 to the power of minus 5. This is nothing but 10 to the power of minus 5. All right, and once you reach this point, you will see that you can bring the minus 5 to the front, which I've done here. I brought minus 5 to the front, and that's log base 10 of 10, and that equals to 1. All right, so the answer is simply minus 5. Very simple. All right, log. Interesting. The base here is not a whole number. The base is square root 5. Very interesting. All right, and what do you notice about this? What do you notice? Square root 5 is 5 to the power of half. 25 is 5 to the power of 2. What's in common? What's in common is 5. Square root 5 is 5 to the power of half. 25 is 5 to the power of 2. What these two numbers have in common is that they have a 5 to the power of something. 5 is common. So because of that, I will take both numbers to the base of 5. So when I change the base, it will be log to the base 5 of 25 divided by log base 5 of square root 5. All right. So here, you know, the base that I'm introducing here, 5, is not guesswork. You know, I didn't guess this. All right. I made a decision. It's a conscious decision because 25 is 5 to the power of 2. Square root 5 is 5 to the power of half. And that's why I've taken to the common base of 5 here. All right. So when I do that, I see that it's 5, log base 5 of 5 to the power of 2. 25 is 5 to the power of 2. Square root 5 is 5 to the power of half. Of course, 2 and half can be brought to the front, which I've done here. 2 and half is brought to the front. And of course, that is log base 5 of 5 is 1 and 1. All right. And that gives me an answer of 4. Really, really, really simple. 2 divided by half is 4. Okay, so I'm introducing this question to show you that the base need not be a nice number. It need not be 2, it need not be 4, it need not be 9, it need not be 7 or something like that. It can be a strange number like square root of 15 and square root of 5, and that shouldn't worry you. All right, it's very easy to handle. All right, the base can be an ugly number, right? Like square root of 5, no problems. We can handle that nicely. All right. Another very weird base, this is half. Can we handle this? Of course. All right. And there's an error here. All right. Error. Embarrassing. It's 128. Okay. So let me get back to that. All right. So there's an error there, which I have just corrected. Okay. All right. So log base half of 128. All right, so again, it's very strange, but what I realize is this: half is 2 to the power of minus 1. What is half? Half is 2 to the power of minus 1. What is 128? 128 is 2 to the power of 7. So what do they have in common? What they have in common is that they are numbers that have a base of 2. So I'm going to express 128 and half as a log base 2. All right. Again, note that this is not guesswork. I'm not guessing. All right. 128 is 2 to the power of 7. Half is 2 to the power of minus 1. And so I take both numbers to the base of 2. All right. I introduce a new base of 2. And I express 128 as 2 to the power of 7. I express half as 2 to the power of minus 1. Okay. And I bring 7 and minus 1 to the front. So I have front and minus 1 here in the front. Okay. And what I do here is this: log base 2 of 2 is 1, log base 2 of 2 is 1 again. So that's 7 times 7 divided by minus 1. And my answer is very simply minus 7. Okay, so very simple. Now, these two questions, I want to stress these two questions. What I'm trying to, these two questions, somebody has their mic on. Can you please turn the mic off? Thank you. All right. So what I'm trying to show you with these two questions is this: your base doesn't have to be a nice number. All right. This one, the base is square root 5, and this one here, the base is half. All right. The base doesn't have to be a nice round number. Okay. We can still deal with it. Okay, let's do this question. Evaluate log base 3 of 1 over square root of 243. And if you remember fairly quickly, you will remember that 3 to the power of 4 is 81, and 3 to the power of 5 is 243. So 243 is 3 to the power of 5, and that's what I've transformed it to be here. So 243 has become 3 to the power of 5. All right, and square root is really to the power of half. So I've transformed the square root here to the power of half here. All right, and you use your rules of indices. This is 5 times half. So you have 5 times half is 5 over 2. And bring that to the top. So that's 3 to the power of minus 5 over 2. And once you have brought that to the top, you can bring this over to the front. So that's minus 2 log base 3 of 3. And that's our familiar 1 here. This equals to 1. So that's minus 5 over 2 times 1. All right. And that's simply just minus 5 over 2. All right. So, it may look very complicated. Don't worry. All right. It looks very complicated. It's not really that complicated. All right. It can be worked out fairly nicely. All right. I think this is the last simple question. All right. Again, log base 16 of 32. And what do you realize? 32 is 2 to the power of 5. 16 is 2 to the power of 4. All right. So quickly be able to work these things out. What's 32? 32 is 2 to the power of 5. 16 is 2 to the power of 4. What do you have in common there? You have 2 in common. All right. So what I'm going to do is I'm going to bring it to a new base. So log base 2 of 32, log base 2 of 16. All right, 32 comes from here, 16 comes from there, and 2 has been introduced. All right, and so what I've done here is this. 32 is 2 to the power of 5, 16 is 2 to the power of 4. I brought it to the front, so 5 log 2 of 2, 4 log 2 of 2, and this is our familiar 1. This is the value of this is 1, and the value of that is also 1. So that's just simply 5 over 4, which is our answer. All right, so the first, 6 or 7 questions, I hope you have an idea of how to solve these evaluate questions. All right, they look rather difficult. Sometimes they can look very difficult, but they are rather easy actually. All right, okay. Okay, now the second evaluate type of question, this is the second type of questions you can see for logarithm. Now here the logarithm appears at the bottom. All right, now sometimes you will see logarithm appear at the top. And how do you deal with that? Okay, it's very simple. Okay, now if your base here is 3, and if your base of your log is also the same number, here we have them as the same number, this whole thing is simply equal to that number. All right, so 3 to the power of log base 3 of 9 is simply 9. All right, now note that this number here and the base number of the log has to be exactly the same for it to equal that number there. All right, so 3 and 3, they are the same, so it equals to 9. Very simple. All right, and this is your general form of the formula. B to the power of log base B of x simply equals to x. That's all. Right, now let's go on to another question. All right, this is 6 to the power of log to the base 6 of 12. 6 and 6, they are the same, so this whole thing simply equals to 12. Very simple. All right, now again, that's a natural number, E. All right. Jeez. What happened to me? What happened to me this week? All right. Now this is an E. All right. So here you have E, raised to the log base E of 3. So you see E and E, same number here. All right. And this whole expression simply equals to 3 then. Okay. And this is the same formula used. Now let's look at something more complicated. So you see E log base E of x simply equals to x, all right, and I'm using this. But how do you do this? You have E here, you have E here, but you have a 2 here. All right, so it doesn't quite fit this formula because here you're not supposed to have any number right in front here. Here you have a 2. So how do you do this? So it's very simple. What you do is just this. You say E to the power of 2 log to the base E of x. Now what you do is this, bring the 2 to the top here. All right, 2, bring it to the top. So that will be E to the power of log base E of x squared. Now how did I transform this? This is 2 brought to the top. So you have x squared here. And now you are in the same, you have the same form as this already. Base log base B to the, of x. And so here the answer is simply x squared. Very, very, very simple. So the whole idea of, the method of solving this sort of questions is for you to arrive at this form. This form is absolutely critical. All right, so you have a b raised to the log base b of x, which is simply equal to x. All right, so if you don't have it, like in this case, you don't have it, what you do is just bring the 2 to the top. All right, so you have an x squared and your value is simply x squared. Really, really simple, right? Okay, now another sort of evaluate questions looks like this. You have 2 LG. Now LG means log base 10. That's what it means. All right, log base 10 is so common that they have got a special notation for it, and that notation is LG. All right, so LG, 2 log base 10 of 5 plus 5 log base 10 of 2. Bring that 2 up, so you have log 5 to the power of 2 plus log 2 to the power of 5. Bring that 5 right up here. And 5 to the power of 2 is 25. 2 to the power of 5 is 32. So that's log 25 plus log 32. All right, and when you add 2 logs up of the same base, you simply multiply them together. All right, so you log 25 times 32 because it's a plus here. When you combine them, it becomes a times. All right, so 25 times 32 is an 800. So log 800, that's your answer. All right, if you want to simplify it further, you could. All right, but that would be correct as well. Let's do another question, something more complicated. All right, so you have half log 9 plus 3/4 log 16 minus log 24. Now the first thing to do is just to bring up these powers. So it's log 9 to the power of half, log 16 to the power of 34, and log 24, nothing to do with that. All right, that's already nice. So the first step is just to bring up these fractions. All right, bring them up to be the power of 9 to be the power of 16. So 9 to the power of half, 16 to the power of 3/4. All right, and 9 to the power of half is simply square root of 9. All right, 9 to the power of half is simply square root of 9. So you have 3 here. 16 to the power of 3/4 is simply 16 to the 4th root is 2. 2 to the power of 3 is 8. So you have log 3 plus log 8 minus log 24. That's what you have. All right, so 9, square root of 9 is 3. 16 raised to the 3/4 is 8, and log 24 over here. Now, once you have this, really simple, 3, it's a plus here, so it's 3 times 8 minus 24, so that goes to the bottom. So 3 times 8 is 24, divided by 24 is log of 1, and log of 1 is simply 0. Beautiful. Very, very, very simple. Okay. Again, something that looks more slightly difficult. You have 2 log square root of 5 minus 3 log 1 over 3 plus log 1 over 270. And the first thing you do is to bring up this 2 and 3 here. So when you bring up 2, it's just square root 5 squared. And square root 5 squared is 5. Square root 5 times square root 5 is 5. All right, so here when you bring up the 3, you have 1 over 3 cubed. And 1 over 3 cubed is 1 over 27. Right, so just write that down. All right, how did I get 5 is square root 5 times square root 5, you get a 5. 1 over 3 times 1 over 3 times 1 over 3 is 1 over 27. All right, that's retained. That's beautiful. All right, so once you have this, use your formula, your logarithmic rules. 5, log 5 plus log 1 over 270. So that has to be a multiply. All right, that's a minus, so that goes down. It's a divide. All right, so do the multiplication and then the division right here. Okay, and once you have done this, it's a matter of spring cleaning. All right, this is messy. It's just messy, that's all. All right, you just spring clean this, and what you have is just 5 times 1 over 270 times 27. And when you simplify that, it's just 5 over 10 really, so half. And if you want to simplify that further, you can say that's log 2 to the power of minus 1, and when you bring that minus 1 down, it's minus log 2. All right, and that's the ultimate. You can't simplify this any further. You've gone all the way. All right, so very simple. Okay, log A, okay, now we deal with some symbols, okay? So far we've been dealing with nice numbers, okay? So it's the same thing with, letters like A, B, and C, right? So you have log A plus 2 log B plus 3 log C. Again, first thing is to bring up these numbers. So here you have log B squared plus log C cubed. Just bring up the 2 and bring up the 3. You have this expression here. This is being added. So what you do is when you combine them, you have log A times B squared times C cubed. All right, and of course, just make it pretty. That's all you have to do is make it pretty, and that's your answer. Very, very simple. So combine this, simplify it, you've got this expression there. Very simple. All right, let's look at some more with kind of a letter. All right, x, a variable there. All right, so let's find out what x is. Let's solve this. All right, so evaluate two log x plus 1 minus half log x minus 1. All right, and when you see something like that, again, bring up the 2, and when you bring up the 2, you have log x plus 1 squared. Where did the square come from? Where did the 2 come from? 2 came out from here. So you just bring it up here, you get a square. All right, in a similar way, you have a half here, bring up the half here. All right, so you take the half and bring it up over here. All right, and once you have done this, it's log of this stuff minus log of that stuff. It's just a divide, that's all. All right, and if you want to make this a little prettier, all right, it looks a bit scary here, so just do this. Your x plus 1 to the power of 2 and x minus 1 half to the power of half here. Half is square root, so just have that over there. Very simple. All right, so it's a simplify question, not evaluate, it's a simplify. So simplify this, very simple. Okay, again, simplify this. You have half log x minus a third log y plus 2 log z. Bring up the half, bring up the 1/3, bring up the 2. Automatic, this should become automatic. All right, when you look at these questions, you should be able to recognize the pattern. Humans are, pattern recognition machines, actually, really. All right, so when you see this, automatically be able to do things like driving a car. You don't think of changing the gear. You don't think too much of what red means. When you see red, you automatically stop, right? So math should be like that. You see a half, bring it up. You see a 1/3, bring that up. You see a 2, bring that up. And that's what you get. All right, so after that, you have a log of x to the power of half is added with log of z to the power of 2. So, that ends up with a multiplication. Minus here ends up at the bottom, divide. All right, and so, again, just pretty things up. X to the power of half is simply square root of x. Y to the power of 1/3 is simply the cube root of y. And that's all you have to do. Simple. Okay, solve for x. This is the first solve for question. Solve for x means give me the value of x, all right, which satisfies this equation. That's the meaning of solve for x. Now it's simple because x plus 5, you have log the base 2 of x plus 5 minus log base 2 of 2x minus 1. Combine them like that. Because it's a minus here, you end up with a divide. All right, from a minus, you end up with a divide. All right, and you have a log expression at the left. You have a number, a pure, beautiful number 5 here on the right. What you do is just x plus 5 divided by 2 minus 1 equals to 2 to the power of 5. So this whole lot equals to 2 to the power of 5. 2 is the base, 5 is the exponent. All right, and after this, it's a matter of clearing things up. You have x plus 5 divided by 2x minus 1 equals to 32. All right, and then after that, you solve it in the usual way. All right, so you have x plus 5 equals to bring up the 2x minus 1. All right, and you multiply that in. 32 times 2 is 64. 32 times minus 1 is minus 32. Do your housekeeping. 64x minus x, and you have 32 plus 5. All right, so you have a 37 equals to 63x. 64x minus x is 63x. All right, and x equals to 37 over 63. All right, and I would leave it to you to substitute all this in to show that it is indeed equals to 5. Right? Okay. Another person with a microphone on, please switch off your microphone. Thank you. Right. Okay. Another question. All right. So solve for x. Again, very similar. The only difference here is the base is 8. All right. That's the only difference. But here you add up two logarithmic expressions, so that ends up to be multiplication, x times x plus 6. Every time you add something here to add two logarithmic expressions, it ends up with a multiplication. Of course, the base has to be the same. You will ensure that the base is the same. All right, so once you have done that, multiply that out. That's x times x is x squared. X times 6 is 6x. All right, on the right side, you have 5x plus 12. So they must be equal. All right, because you have log 8 of this equals to log 8 of that. Both these expressions must be equal, so equate them. Once you have equated them, form your quadratic equation. All right, and once you have formed your quadratic equation, go ahead to solve your quadratic equation. So when you solve it by factorization, by method of factorization, you have x plus 4 times x minus 3. And that gives you the answer of x equals to 3 and x equals to 3 from here and x equals to minus 4 from here. Now, when you see answers like that, you immediately can strike this one out. All right, you can strike this one out. And you can strike this one out. How come I'm so quickly able to do that? Because you can't take the log of a minus number here. You cannot take the logarithm of a negative number. So here, if you have your solution as minus 4, here it's log base 8 of minus 4, which is not right. It's undefined. Okay, so immediately because of this expression here, I can knock that out. All right, simple. Now let's go on. We have solved for x and this expression here. Again, simple. You have the addition of two logarithmic expressions here. It ends up being multiplied together. So that's x times x minus 9. Before you do this, you've got to make sure that the bases are the same. So the base 6 here, the base 6 here, you can do it. All right, if the bases are not the same, you cannot do this. Okay, so I'm doing this because the base is both the same, 6. All right, and so once you've done that, very simple, x times x is x squared, x times minus 9 is minus 9x. All right, and x squared minus 9x is simply equal to 6 to the power of 2. 6 is the base, so 6 to the power of 2. Some students have a problem. They think, okay, they're wondering, okay, is it 2 to the power of 6? Is it 6 to the power of 2? What is it? All right, now remember, this is the base. So it's got to be 6 to the power of 2. 6 here is the base. All right, so it's 6 to the power of 2 there. All right, of course, expand that becomes 36 and bring the 36 over. 6 squared is 36, so bring the 36 over, that becomes minus 36. And factorize that again, you can nicely factorize that. So the factors are x minus 12 and x plus 3. So once you have that, you can get your answer. X equals to 12 and x equals to minus 3. And again, you will see that there's a log base 6 of x here, and there's a minus 3 here. Log base anything of a minus number is not defined, so you knock that out instantly. All right, and before you exit the question, really you should test 12 out to see that it is in fact the solution. All right, I'll leave that to you. All right, substitute 12 in and you will see that it is the solution. All right, something very simple. I've showed you LG. LG is log base 10. Now this is ln. ln is log to the base of e. All right, so you've got two special notations. LG is log base 10. ln is log base e. So once you have something like that, it's very simple. That means 6x minus 5 is e. E is the base to the power of 3. So e to the power of 3. All right, so you have e to the power of 3 here. All right, and from here it's just tidying up. 6x equals to e to the power of 3 plus 5. And of course, use your calculator, just divide the whole thing by 6. X equals to e to the power of 3 plus 5 divided by 6. And that, if you use your calculator, you'll see that that gives you an answer of 4.1809. Okay. I'm getting a warning which says my power is low. So let me plug in my power. Okay. All right. Okay, let's go on to the next question. Something looking rather strange. 0.49 to the power of x plus 1 equals to 0.62 to the power of x. How do you do that? All right, now, very simple. Just repeat the question, all right, and break this apart. All right, break this apart. All right, and when you break this apart, that's what you get. All right, so it's 0.49 to the power of x times, this is a times here, 0.49 to the power of 1. So breaking this apart is really critical. All right, now break this apart so that you can bring all the x terms to one side. Why do you need to break this apart? Why are you breaking this apart? You're breaking this apart. I'm breaking this apart so that I can bring the x terms to one side and the terms which contains numbers to the other side. I can do separation. All right, need separation. So that's what I get. 0.62 to the power of x divided by 0.49 to the power of x equals to 0.49. All right, 0.49 to the power of 1 is simply 0.49. Now, how does this help? All right, this helps because I can combine these two to become this. That's how it helps. All right, so now you will see that, let's go back again. I have separated this into 0.49 to the power of x, 0.49 to the power of 1. Why have I done this? I have done this so I can separate it, all the x terms, the terms containing x on one side, the terms containing no x, free of x on the other side. And, you know, I can go further and do this. And how does this help, right? Now, this helps in this way. All right, this is the base. All right, this to the power of x equals to 0.49, which means x equals to log to the base of, remember this is the base. All right, this is the base. So log to the base of 0.62 divided by 0.49 of 0.49. That's what it means. All right, and of course this looks absolutely horrible, right? This looks absolutely crazy. What have I done here? Now this is simply log to the base 10. Note that I've changed the notation to LG. So this is log base 10 of 0.49 divided by log base 10 of 0.62 divided by 0.49. So this you need your calculator, and bring out your calculator, hit your calculator keys, and you get this answer here. Very simple. Okay, this is special question. All right, it looks scary, but systematically, if you break things down, and if you know your logarithms very, very well, if you know your logarithmic rules very, very well, you will be able to handle this, no sweat. Okay, so remember, combine this into this format, and remember, this looks scary, but whatever this is the base. This is nothing but the base, and therefore I can put this right down here. This is the base. All right, it looks scary, but it's correct, and of 0.49. And change of base to 10, use your calculator and get an answer of minus 3.03. Okay, let's go on to another question. So again, solve for x. Simple again. You have x squared minus 6x, 3 to the power of 3. So this is the base. This 3 here is the base. It's the base. This 3 here goes on the top. All right, so this 3 becomes the base. This 3 becomes the top here. All right, and of course, this is equal to 27. And bring it across, factorize, and x equals to 9, x equals to minus 3. Okay, and you will see that both of these, okay, when you substitute in, you will see that both of these are indeed solutions. Both are solutions. All right, I don't have to cancel out anything. I'll leave the verification step to you. I'll leave the testing step to you. Okay, now this, you can see that I didn't type this, right? I didn't type this because this comes from one of the secondary school questions, man. Somebody sent me a secondary school test paper, and I just cut off this question from the secondary school test paper. All right, and I'm going to do secondary school test papers from now. All right, so I'm just going to cut it, and I'm going to answer them one by one. So solve the following equations, this and that. So let's do one by one. So this is the first one, right? I've just made it really big. So here, the first thing is this, you know. Look at what stands out, what sticks out, what looks ugly. Now, what looks ugly is this one here. It's really, really a pain because it sticks out like nobody's business. So here, instead of a 1, you have a log base 2 of 2. That's what you do. Transform this one to log base 2 of 2. And why log base 2? Because the rest are already log base 2, log base 2. So 1, transform it there. And once you have transformed this, it looks a lot nicer because you can add these two up to become log base 2 of 14. 2, this is plus, right? So it ends up with it being a times. All right, and you this 2 bring up there, so you have a log base 2 of x minus 5 to the power of 2. Where did this power of 2 come from? This 2 is brought up. Okay, so once you bring this up, just expand it. So that's x squared minus 10x plus 25. And so you have it. This side is 14. This side is x squared minus 10x plus 25. And I can do this, I can proudly do this because it's a base 2 here and it's a base 2 there. You have to check before you do bold things like that. All right, this is a very bold step that I'm taking, and I'm allowed to do this because the two bases are the same. If this is base 2 and this is base 8 or something like that, I couldn't do it. All right, but I can do it because they are the same base. Now, once I've done that, you know the drill. Form your quadratic equation, and believe it or not, it looks like this can be solved using factorization. It cannot. All right, it absolutely cannot be factorized. So what I've done is I've used the quadratic formula to solve it. And when I use the quadratic formula to solve it, we've gone through all these things already. When I use the quadratic formula to solve it, I get two answers, 8.7 and 1.2. And I'm going to knock that out. And why am I not knocking this out so quickly? Because 1.258 minus 5 is going to give me a negative number. That's going to give me a negative number. So log of a negative number is a no-no. It's undefined. It's a no-no. So I'm going to knock this out. And so our only answer, which I will leave you to verify, is 8.741. That is our only answer. So if you put this 8.741 inside here, you will see that everything checks out nicely. Okay? Okay, of course, this needs a calculator. Okay, this is the second part of the question. And again, it's simple. So you have log base 10 of 7x minus 1 plus log base 10 of x plus 2 equals to 2. It's already neat. And this is shouting at you, you know. It's shouting at you to multiply it. So that's what I'm going to do. I'm going to multiply this thing. All right, so when you add up these two logarithmic expressions, all right, because it's an addition, you multiply them, all right, when you combine them. So just multiply it. So 7x times x is 7x squared. 7x times 2 is 14 minus 1, so that's 13x. So minus 1 times 2 is minus 2, and that 2 comes from there. All right, okay, and what do you do here? This is log base 10. So 7x squared plus 13x minus 2 is 10 to the power of 2. So that 10 comes from base 10 here. The 2 comes from over here. Right? So the base to the power of 2. So 10 to the power of 2. And that's 100. All right? Bring it over, form your quadratic equation. So that's minus 102. Form your quadratic equation, factorize. And then after that, you have two solutions, x equals to 3 from here. This solution here with x equals to 3. The solution here is x equals to minus 34 over 7, which you knock off. And you knock that off. Why? Because minus 34 over 7, when you substitute over here, you get a negative number, which again is a no-no. All right, so you knock that off quickly. And your only answer, which I leave you to verify, is simply x equals to 3. When you bring x equals to 3 and substitute in here, you will see that everything checks out. Okay, another two questions from exam papers again. Every time you see this blur stuff, you know, it's a little bit fuzzy. You know I've snipped it from somewhere. I didn't type this. All right, so again, there are two questions here. Let's do it one by one. So given that, this is the first one. Given that log to the base x of 8 is 3 over 4. Evaluate this other thing. And look at this. You have 8, you have 4. 8 is 2 to the power of 3. 4 is 2 to the power of 2. That should give you some, you know, hint that you should convert to, you know, base 2. Because 8 is 2 to the power of 3, 4 is 2 to the power of 2. So this is exactly on the left side, and this is the one on the right side. So this is what we are trying to evaluate. This is what we are given. So let's work through these things systematically. This is just this, and this is what we are trying to do. So here, because x is 8 is 2 to the power of 3 and 4 is 2 to the power of 2, what I'm going to do is I'm going to change this to log base 2. So that's log base 2 of 8, log base 2 of x equals to 3 over 4. I've just changed this to this. That's all I have done. All right, and log base 2 to the 8 is simply 3 because 8 is 2 to the power of 3. So you see I'm doing quite a lot of things mentally. All right, 8 is 2 to the power of 3. 8 is 2 to the power of 3. When I bring 3 down, log 2, that's 1. So that equals to 3. All right, and from all these stuff, I can get the value of log base 2 of x, which is equals to 4. Now, I'm going to sort of tuck that away by the side, and I'm going to leave this for a while. I'm going to leave this for a while and look at what I have to do on the right side. Okay, what I want is to evaluate log base 4 of 1 over x, and 1 over x is simply x to the power of minus 1. And then after that, I'm going to bring this minus 1 down, which I get this. This is simply the same thing, but with minus 1 brought down. All right, and after this, what I'm going to do is I have this log base 2, but this is log base 4. Log base 2, log base 4. Log base 2, log base 4. So I've got to make this, conform to this. I've got a value for log base 2 of x. So I've got to somehow, wrangle this, massage this, such that I get to use this. And that's what I have. So log base 2 of x, log base 2 of 4. Now I get to use this over there. All right, so I get to use this right over here. And when I use that over here, it's 4. And this, of course, is just 2. So that's minus 2. Very simple. All right, so that's how this question from one of the secondary schools, I don't know which one, the test paper didn't have a cover page. All right, anyway, this came from one of the secondary schools. Very, very easy to do. All right, so kind of do both, settle this, get an expression for log base 2 of x, and tuck that away. Keep that aside for a while until you need to do it. You need to use it here. Okay, the second part of the question, you have log base x of y plus log base y of x. Gosh, the other way around. This one here, the base is x. This one here, the base is y. Minus 10 over log base x of y equals to 0. Now, if you look at this whole thing, just look at this. Which is the odd one now? The odd one now is this one here. Here you have log base x, log base x. This one log base y. This is the odd one out. So we're going to make this conform to the rest. The idea here, the strategy here is to identify the odd one out. The odd one out is here. It sticks out like a sore thumb. So we're going to make it conform like that. Right? So now we have changed it to log base y of x equals to 1 over log base x of y. And you see now that everything is the same. Now we are getting our house in order. All right, the whole question is coming into play. So 1 minus 10. 1 here minus 10, your base is the same. 1 minus 10 is minus 9. So how did I get a minus 9? It's 1 minus 10 minus 9. All right, and of course, bring it over to the other side. All right, so bring this whole thing over to the other side. You get log base x of y equals to 9 over log base x of y. Now, once you have done that, this is the same thing. All right, bring this up and you have log base x of y squared. The whole thing squared. All right, because we have this times this, so the whole thing squared. And that is simply plus minus 3 lah. All right, now the question says express y in terms of x. And this is not expressing y in terms of x. All right, express y in terms of x means y equals to something. All right, and this is not y equals to something. So there's an additional step, and that is y equals to x to the power of plus 3 and y equals to the power of y equals to x to the power of minus 3 here. All right, so this is express y in terms of x. This is it, and that's it. All right, the plus 3 ends up here, the minus 3 ends up there. And of course, you can go one step and express it like that. No problems. Okay, this is another fuzzy question, which means that it got snipped off somewhere. I've made it a bit clearer here. I've retyped the question over here for you. It's very simple again. All right, And this is log to the base 3 of 10 minus 9x, this which is here. And this is minus 4, which is minus 4 here. And this is log base 9 of x. And what I'm going to do, what I've done here is simply, I've changed the base from 9 to 3. So that's log base 3 of x divided by log base 3 of 9. And why have I chosen 3? I've chosen 3 because 9 is 3 to the power of 2. And 3 is used here. This 3 here gave me a hint, kind of a hint that I should be changing everything to 3. So I've changed that. All right, because it's log base 3 here, log base 9 here, it's not compatible. It's like Apple and Mac. They don't talk to each other. So this is Apple and that's Mac. You've got to change it to log base 3, which I've done. Now you've got Apple and Apple. All right, so now this can be easily changed to 2 because 9 is 3 to the power of 2. Bring the 2 down and you got 2 here. All right, and 4 divided by 2 is simply 2. So I'm just doing housekeeping. Nothing but housekeeping. I'm taking the feather duster, I'm taking the broom, I'm taking the mop, and I'm mopping the house. All right? And 2 can be brought up, which I'm going to bring 2 up in the next step. So you can see the 2 gets brought up here. And this minus means that these 2 expressions here got to be divided, which I've done here. All right? And 10 minus 9x divided by x squared simply is equal to 3 to the power of 2. 3 is the base. So it's equal to 3 to the power of 2, which is here. All right, how do I know 3 is the base? Because 3 is the base here. 2 is the exponent. All right, 3 to the power of 2 is 9. 9x squared, all right, and change that into a quadratic equation. All right, and of course, once you have that as a quadratic equation, factor this. So 3x times 3x is 9x. Minus 2 times 5 is minus 10. 3x times 5 is 15x. Minus 6x equals to 9x. Okay, and your answer is x equals to 2 over 3. From here, your answer is x equals to 2 over 3. From here, your x equals to minus 5 over 3. And you will see that the minus 5 over 3 can be knocked out instantly because of this term here. You cannot put this minus 5 over 3 in here. It's undefined. So knock that out immediately. All right, and again, I will leave this to you to verify that it is indeed the answer. Okay, so if you guys have questions, I don't have the exam papers for secondary schools. There are so many secondary schools here in Singapore and elsewhere. If you have these exam papers, please send them to me. All right, please send them to me so that I can cut and paste, snip and paste rather some of these questions and do them for you. Okay, same. Now, this is a question I told you, this is an Apple and, Windows. It doesn't, iOS and Windows, it doesn't talk to each other, you got to convert one to the other. Same. This is a similar type of question, exactly the same type of question. You have an iOS and you have Windows. Or you have iOS and Android, whatever it is. It doesn't talk to each other. So you've got to convert one to the other. All right, so 25 is 5 to the power of 2. So I'm going to convert this base of 25, I'm going to convert it to the base of 5. All right, so these two questions share this thing in common. You have different bases, you have two operating systems, iOS and Android, and you've got to convert the two operating systems. You've got to convert one operating system to the other so that they can operate. All right, so I'm going to convert log base 25 to log base 5, and that's how I've done it. So that's log base 5 of x plus 10, and that's log base 5 of 25 equals to 12. So this has been converted to that. Now, understand the reason. Why am I doing this? I'm doing this simply because I cannot do anything with log with two different bases. That's a dead end, man. That's an absolute dead end. I cannot do anything with that. So I can only do things if the bases are the same. All right, so many of the log questions end up like that. How do you convert them so that the base is the same? All right, so once I've done that, log base 5 of 25 is simply 2, because 25 is 5 to the power of 2. Now what do you do here? Now you have this and then minus that over 2 equals to 1 over 2. Now the thing that this, the thing that begs to be done here is to multiply throughout by 2. And you multiply throughout by 2 so that you can get rid of 2 at the bottom. Understand why you are doing this. Why are you multiplying throughout by 2? You're multiplying throughout by 2 because You want to get rid of this 2 at the bottom, and once you multiply it by 2 throughout, that's what you get. You get a beautiful equation here. Absolutely, absolutely, absolutely beautiful. And then after that, bring up the 2, you get this 2. You bring up 2 here, you have log base 5 of x squared. All right, and because it's the minus here, you have a divide here. So x squared on the top, x plus 10 at the bottom because of the minus here. And 5 and 5. Look at what can be done if I have the same base. If I have 5 and 25 like up here, it's hopeless, it's futile, absolutely futile. So once I have converted to base 5, I can do this equals to 1, and now that I can introduce this 5 to the power of 1 here. So x squared over x plus 10 equals to 5 to the 1. So how do I get 5 to the power of 1? 5 comes from there, base, and 1 becomes the power. All right, remember 5 is the base. 5 appears at the bottom. Remember, at the bottom, at the basement, that's your base. 5 is your base. 1 is the power. I'm telling you over and over again because, in my many years of teaching, I've often encountered students who will put 1 to the power of 5 here. And I'm wondering, how did they get 1 to the power of 5? How did they get 1 as the base when it's so clearly here that 5 is the base, is at the basement, so 5 to the power of 1. And after that, just do your thing. 5 times x is 5x, 5 times 10 is 50. Get your quadratic equation, factorize the thing, and your two solutions are, what's your two solutions? X equals to 10 and x equals to minus 5. And because of your log base 5 of x here, you can knock that out. All right, because log base anything of a negative number is a no-go, is an undefined. So what you're left with is simply your other solution, x equals to 10. And again, I will leave it to you to verify that this is indeed the answer. All right, okay. This is a slightly longer one. Today, I will really stick to 1 hour, okay? So I prepared fewer questions, but this is one of the long questions I prepared. Now, given that y equals to e to the power of natural log of 3, square root 3, show that y equals to square root 3. Hence, this magical word hence is here. Without using a calculator, evaluate this lot. Now, let's just do this part first. All right, let's just do this part first. So you have that. All right, y equals to e to the power of natural log of square root 3. Now, what I've done here is to take natural log on both sides. I've taken natural log of y, and if I take the natural log of the left side, I have to take the natural log of the right side as well. It has got to be fair. So natural log of y equals to natural log of this whole lot of things here. Now, once I have done this, look at it. This is e to the power of all that, right? I can bring this down. What's happening here? What's happening here? What's happening here? I brought this power here. I brought it down. And what's natural log of e? Natural log of e is simply 1. Try that in your calculator, you will get a 1 there. All right? And y is therefore equals to square root of 3. All right? Because this is a 1, y is therefore equal to just square root 3. And I have shown that y equals to square root 3. There. That is the showing. All right? Now, once I have done that, hence, I have to say hence without using a calculator, evaluate this monster here. This is a monster of an expression. So what you do is just look at this. Okay, I've just repeated it over here and just square root of 3, put it over here. That's all. That's all you have to do. All right, so that's what we're going to do in the next slide. So you will see that this one here, which is just from here, what I've done is just I've taken this whole lot here. From the first part, I've replaced it with square root of 3. All right, the half here, I've taken it to the top, so it becomes square root of 9. All right, where did the square root come from? Because I took the half to the top, so square root of 9. All right, and here, what I've done is I've changed it to 1 over log base 3 of 9. I've swapped position by taking 1 over there. Okay, now, there are a lot of transformations here. Make sure you understand how this is done. Now, how did I transform this to this? I transformed this to this from part 1. Now, how did I transform this to this? I transformed this to this by bringing the half to this. So it becomes 9 to the power of half. 9 to the power of half is square root of 9. How did I transform this to this? All right, by taking 1 over that. So when I take over 1 over, when I invert that, these two numbers flip. So 3 becomes at the bottom, 9 becomes on the top. All right, so after I've done all these things, look at the next step. Square root of 9 is 3. All right, log 3 of 9 is 3 to the power of 2. And this simply equals to 1. This simply equals to 2. So that's 1, and that's 2 over here. And you have your answer, 2 square root 3. Simple. So you have your monster here. Evaluate this, and the monster has been tamed to just 2 square root 3. That's all. Simple. All right. Okay, let's go on to another one. And this is, although this is not, doesn't look fuzzy. It doesn't look like, blur. It's also snipped. Also, it's been snipped from an exam question. So this is another secondary school question from one of the Singapore secondary schools, I'm guessing. All right. So here, immediately put that down. Okay, and what have I done here? What did I do to get to this step? So here, log to the base 1000, base of 1000, gosh, all right, of x squared plus 9 minus log to the base 1000 of x. All right, so this looks scary, just x squared plus 9 divided by x. That's all you have. So this is the first step, very, very important first step. All right, so understand, I'm just doing one step. And that's just combining these two. And when I combine these two, I get log base 1000 of x squared plus 9 over x. This x appears at the bottom because of this minus here. Now, the next thing to do is to get this 3 at the bottom. So the next thing is this 3 is going to disappear. It's going to appear right at the bottom here. All right, that's what happened there. Okay, now the next thing that's going to happen is this 27 is going to be raised to minus 1/3, like that. 27 is the base, minus 1/3 is the power. Remember, this is at the basement, it's the base. It's at the basement, it's where you keep your rubbish, keep your stuff that you don't need, right? It's the basement. So that's your basement, raised to the power of minus 1/3. So that's that. And once you have that, 27 raised to the power of minus 1/3 is simply 1/3. All right, it's simply 1/3. Okay? And next thing to do, I'm going to repeat this over here. This gets repeated over there. The next thing, what happens is you take 1000 to the power of 1/3. That's it. 1000 is the base, 1/3 is the power. And 1000 to the power of 1/3 is simply 10. All right, and you got your quadratic equation, and you can solve your quadratic equation. X minus 9 times x minus 1 equals to 0. All right, and your two solutions are x plus 9 and x plus 1. All right, x equals to 9 and x equals to 1. And I'm going to leave this to you because you'll be able to show that when you plug this into here, you will see that it works out. So both are, I don't have to knock anything out. Both are solutions, okay? All right, something really fuzzy. All right, I've snipped from somewhere clearly. Log 9, log base 9, log base 3. What do you have to do? It's iOS and Android. All right, iOS and Android. So you've got to make everything standard. You've got to make it standard. Why do you want to make everything standard based? Because you want to apply the rules of logarithms. So they have to be the same base. So 9 is 3 to the power of 2. So I'm going to make this base 3 and base 3. That's all. So every time, you have log to two different bases, immediately, you must realize that you have to make it to the same base. This must be automatic. This has to be automatic because two different bases, they can't talk to each other. One chicken and one duck. They can't converse. They can't have a proper conversation. One is iOS, one is Android. So make it to the same base. You have log base 3 of this lot and log base 3 of 9. This becomes 2. Right? And what is begging to be done here? You have a divide by 2, you have a divide by 2. What do you need to do? You need to get rid of the 2. it's irritating you, you know. This 2 at the bottom and 2 at the bottom is irritating you. So how do you get rid of the 2? You multiply throughout by 2. That's what you get. All right. Once you multiply out throughout by 2, you see that you got rid of the 2 over 2. You got rid of it, but you introduce a 2 here. So what do you do with the 2 here? You bring it to the top. So that's what you bring. The 2 here comes to the top. It's standard, really, really, really standard, okay? And once you have this, what do? You combine these two by dividing the lot. So 4x squared plus 3x plus 5 appears at the top. X plus 1 squared appears at the bottom. I'm putting it here because I've run out of space. Okay, and a 1 is just 1 here. And what do you need to do next? What you need to do next is to expand this and to bring 3 to the power of 1. 3 is a basement, so it's 3 to the power of 1, which I will do here. So expand, you know, I will expand this, and this is 3 to the power of 1. So expand this. X plus 1 squared is x squared plus 2x plus 1. It's just an expansion of that. Bring that up. Expand it. 3 times x squared is 3x squared. 3 times 2x is 6x. 3 times 1 is 3. All right? Make, you know, form your quadratic equation. 4 minus 3 is just 1. 3 minus 6 minus 3. 5 minus 3 is 2. And then after that, factorize and get your solutions. Right, get your solutions, and you will be able to show that both of them qualify. All right, both solutions are okay, are good to go. All right, so it's standard. I hope you know by solving a lot of questions, you get to see the pattern repeat itself over and over again. Okay, now this is the last question I'm doing for today. I promise I will keep it to 1 hour. So the next time I will see you, it will be June 22nd. So we'll take a 2-week break. All right, and let me tell you what's going to happen from June 22nd. Now, up to now, what I've been doing is I've been solving questions, and you've been coming online to view these questions. Now, I'm trying to do it like that. I'll send you the questions, and you go try it out. All right, you can go try it out and so on and so forth, and we can work it out together. You can come on the day, and we can work out together. All right, so June 22nd, I'll be talking about word problems concerning indices, surds, and logarithms. Indices we did 2 weeks ago, surds we did a week ago, and logarithms we completed it today. Now, these problems are problems I've obtained from, again, these test papers, and I'm going to go through them, and I'm going to show you how to solve them. And I've got 2 or 3 questions here for you, just to give you an idea of what we're going to do on the 22nd. All right, so a population of a certain type of bacteria P at time T hours is given by this, where P naught is the initial number of bacteria, blah, blah, blah. The bacteria doubles every 7.5 hours. Given that there were approximately 100 bacteria to start with, find the value of K, the approximate number of bacteria that will be there in 2.5 days. So I'm going to do questions like that. All right, this is another one. I'm not going to read through it, but you get the idea. These are word problems concerning indices, surds, and logarithms, and we're going to do not next week, but 2 weeks from now. So I will see you on June 22nd. I hope you've benefited from it. And again, if you have questions and so on and so forth, if you have questions, because I'm running out, all right? If you have questions, send them over. All right? So thank you for watching, and I'll see you not next week, but in 2 weeks' time on June 22nd. Thank you, and bye-bye.